All right, let's talk about the two terms instantaneous and average. So in questions from textbooks or from me or from the internet or other teachers, you'll often hear them ask for instantaneous speed or velocity, find it, or an average speed. So instantaneous is right at this moment. They're going to give you one time and they want to know what is the velocity at that exact time. Average is usually they'll give you two times, like an average from 5 seconds to 10 seconds or 0 seconds to 20 seconds. I just want to show you how to do that. So let's say that I've got a DT graph. The slope of a line equals which one of these three from a displacement time graph? From the last video, we'd know that it is velocity. If it was no little vector sign here, I'd be finding speed, because then it would be a distance time graph. Acceleration we'll learn about real soon in terms of graphing. So the instantaneous, velocity here is the slope of this line. And since the slope of this line is straight, and the slope would be the same at any single point along this line, I'm always getting the same. All the instantaneous velocities would be the same, and all the average speeds, because no matter what 2 points you chose, those two, these guys, this guy, and this guy, I'm always going to get the same answer. So over here, straight line graphs are easy. Let's say that they are for little kids. Okay? All I have to do is find the slope. But what happens if this graph is curved? So this is for instantaneous first. So like I said before, I will get a specific time, yes, in the question. Let's say that it's at this time right here, at let's say 5 seconds. So I see 5 seconds, I get it on the graph, I go and I draw a point at there, and then I draw a tangent line, and this is going to look really rough because I'm free-handing it, but I draw a tangent to the curve at that point, and this line, tangent, should only touch the curve here, only here, no other point. So I should draw a tangent, and then I should find the slope of that tangent. Will give me the instantaneous velocity at the time 5 seconds. So I find the slope. So I would take 2 points, this point and this point. I draw my little triangle, and there's my rise, and there's my run, and I write slope equals rise over run, and I plug in my two numbers there, and I get an answer. Yes? That's how I deal with instantaneous when my graph is a curve. I draw a tangent line that only touches the curve at that point, and I find the slope of that tangent. If I'm asked for average, I said before, we need 2 times given. So let's say it's here and here. What I do here is I draw a line between these 2 points, and I'm going to do my best to draw a straight line between these 2 points. This thing here is called a secant. And so I draw a secant between the 2 times of interest to me, and then I find the slope of that secant. And here, same thing, I'll choose 2 points on the line. I'll write my little triangle, I'll do rise over run. I'll write slope equals rise over run. I'll plug in the numbers and I'll get a value. Boom. So, summing up, straight line graphs are for little kids. Find the slope of the line. If I'm trying to find an instantaneous velocity or speed or acceleration, I draw a tangent at the specific time I'm given, find the slope of the tangent. If I want to find an average speed or velocity or acceleration, I need 2 times. I draw a line between them, those 2 times. It's called a secant. I draw the I draw my little triangle, and I find the slope of that secant. Boom, and I got my average right here. And that's it. Later.